Welcome to lesson 70. Howdy. Solving inequalities by multiplying or dividing. If you have been with us for a while, you will remember that in lesson 66 we did the exact same thing as we're doing today, except we did it with addition and subtraction. Today we're going to investigate how to do this with multiplying or dividing. And in 66, I told you that the rules are the same for inequalities as they are for equations. Equations have equal signs, inequalities have signs like this. Greater than, less than, or also equal to. We looked at whether we fill in the circle or we leave it empty, and then which way the arrow goes when we write the graph. The rules are almost exactly the same for multiplying and dividing, except when we talk about negative numbers. So that's the only thing that we're going to have to be extra careful about today. So hopefully you've got your pencil and your notebook, taking notes. You're going to have your paper for doing your homework, and boy, a healthy snack sure comes in handy, and an oversized mug in which to recaffeinate once you're done. Okay, so I'm really not going to go over too many of the actual examples there in the book. You can see how they've graphed things probably better than I can do it up here on the board. I want to give you the broad strokes behind why we're doing what we're doing when we get to the tricky part. Okay, so we're always going to be working with a number line here. And before I get to number lines, I want you to go back in your math book all the way to the very beginning to lesson 1, where it has a classification of subsets of numbers. It seems like the number theory part of it kind of seems the part that nobody ever remembers and knows how to deal with, but is very important to knowing the types of answers that you have and why, in a sense, the rule that we're going to look at today works the way that it does. So I've got 3 sets of different kinds of numbers right here. We start off with the natural numbers, which, or sometimes you call them the counting numbers. It's the ones that you started with, 1, 2, 3, 4, 5, etc. Okay. The next set is whole numbers. The only thing that's added to the set of natural numbers to make it whole numbers is the number 0. But no negatives, just starting with this. It's just now we got this new concept that you can have nothing as being something. Those are the whole numbers. The number line that we use here is actually called the real number line, which is even bigger. But the main thing that we look at on number lines with inequalities are integers. And integers include 1, 2, 3, 4, 5, include 0, as well as the opposites of all the natural numbers. And when we say opposites, all I mean is that we have the negative version of everything in the natural numbers. And if you look at my number line here, I've got a little dotted line here at 0. You remember doing absolute value, the absolute distance from any place on the number line 2 to 0. So we know that negative 3 has an absolute value of 3. It's 1, 2, 3 places away from 0. So we have this number line here, 1, 2, 3. We include 0, and now we just take 1 and we find its opposite. That is, its reflection over that little dotted line where 0 is at. The reflection of 1 over this line is negative 1. The reflection of 2 over this line is negative 2. The reflection of 3 over the opposite of 3 is negative 3. It's still the same distance away from the origin, from 0, but it's the other direction. It's going in the opposite direction as our regular natural numbers. These are the opposites of the natural numbers, and that's what makes up the number line. You'll see in a few minutes why I'm talking about this and why that's important to kind of have that in the back of your brain to understand why the rule works the way that it does when we get to negatives and multiplying and dividing. Okay, so let's just imagine we got 2 numbers here, A and B. Maybe we already know where they are on the number line, and maybe we don't. Maybe we have one of those answers like x is greater than 2. Okay, it doesn't matter where these things are. Let's say that A is here and that B is there. And this would be the case where A is less than B. Okay. We know then that in lesson 66, if we added 2 to each one, it would just take these and move them 2 down our number line, and it would still be true that A is less than B, if that was the case. So adding and subtracting, just pick these things up and move them to the left or to the right, but they move them both the same amount, and so that inequality is still true. Well, today we're going to be multiplying and dividing these whole numbers. So let's say we're at 1 and 3 again for A and for B. And we do the same thing to both sides. We're going to multiply them both by some value C. Okay? Let's imagine, in our case here we got 1 and 3, that our number is 2. We're going to multiply both 1 and 3 by 2. Okay? So 1 times 2 is 2, and that moves that point right there. B, if it's 3 and we multiply it by 2, it moves out 6. And you can see that no matter what you multiply it by, A is always going to be less than B. It's even going to be more or less than it was before when we do this multiplication. Even if you multiply it by a small number, let's say that C is 1/2. Let's get rid of that. Put B back here. We say we multiply A by 1/2. 1 by 1/2 puts it right here. And we multiply 3 by 1/2 and it moves it here. But no matter how much we divide it by, A is always going to be further to the left than B is. They might get closer to each other, but A will always still be less than B. Multiplying and dividing by some constant does not change the direction of that arrow as long as the constant is a natural number. As long as it's a positive number. So in the book, the first rule that you have, if you're looking in the book on page 456, it says if A is greater than B, then A times C is, it switches the sign. Oh yeah, that's fair. Okay, on page 455, that the sign does not change. So they said, if this is true, then this is also true. And that, again, that is true for both multiplication and division. Division is just multiplying by a fraction, okay, by the reciprocal of a natural number. So this is the exact same thing as saying A divided by C and B divided by that same number. The arrow does not change directions. It's always going to stay to the left or to the right of that other number. That will never change. Okay? If we're dealing with natural numbers and they're positives. That's why on that first rule it says if C is greater than 0. That's just a fancy way of saying C is a positive value. C is a positive value. It's greater than 0. It must be positive. So the rule works for multiplication and division in the exact same way. For C being positive, either we're multiplying by a fraction or multiplying by a whole number here, a natural number or a real number, but it's a positive real number. And A will always stay in the same relation to B. It'll always be greater than or less than it was before. The trick comes when we switch that and we turn this around and we say when C is less than 0, or that is when it's a negative value. And I can demonstrate that with our A's and B's here. Let's say again A is 1 and B is 3. Okay? If A is 1 and B is 3, we have A being less than B. But what if I'm going to multiply both of these by C and C is negative 1? A now goes to its opposite value and jumps over here to negative 1. Okay? And B, being multiplied by negative 1, it jumps over here to its opposite at negative 3. Now, 3 is a bigger value, But this is negative, and we're just saying how far to the left or to the right. And numbers that are further to the right are of greater value. They are bigger than numbers that are further to the left. And now A is over here, but B is even farther this way. So now we'd have to say, if we did this, if C was -1, we multiplied C by A and B by a negative number, and we basically now we have negative A and negative B. The arrow turns around. Negative A, -1, is bigger than negative B. It's now -3. Okay, so if you're going to multiply or divide by a negative number, the little alligator, the little arrow, it changes directions. It was pointed this way here, but once we hit that negative to it, it turned around this way. So that's the trick, and that's the thing that you need to watch out for when you're doing your math. If ever you're going to divide or multiply both sides by a negative value in order to simplify your problem, you have to turn that inequality sign around. You only have to do it when you're dividing or multiplying by a negative number, but when you do that, you have to do that. So let's do the division thing here too. Let's say we divide, we're going to multiply or divide A and B by -2. Okay, we're going to take 1, A is 1, and we multiply it by, or sorry, divide it by -2. 1 divided by -2 is -1/2. And 3 divided by -2 is going to be -1.5, or -3/2. And that would put it right here. So you can see, again, it doesn't matter if I was multiplying or dividing. I divided by, and it moved it over here to this side of 0, but B moved further to that side of 0. And so now it is still true here that if we do that and C was equal to this, then now A over C, if that was true and this is true, and this turns this way, that's B over C, that we have to change the direction, which means we're going to have to change the direction that our arrow goes when we draw out our answers. So if -2x is greater than 4, that's our original statement. When we go to solve this and we divide both sides by -2, we do the math here and we say -2, but then we change that arrow around so that it's pointed in the opposite direction. And then we graph it the exact same way that we did when we were in lesson 66, when all we were doing were adding and subtracting. So watch for negatives. They will switch your inequality around, and your arrow will be pointed in the opposite direction than it was before. That's basically it. The rest of the examples and whatnot are just versions of that. Your answers are primarily number line types with circles filled in if it's also equal to, or left open if it is just greater than or less than. And then just make sure that you know which way your arrow needs to go. That's all for lesson 70. Once you finish lesson 70, please contact me and I can send you the test 13, which goes through lesson 65. Please do that. I want to know where you're at and get you the stuff so you can get it done so that you don't have to do this all over again. Thanks for watching.